Now exactly what an armillary sphere was used for, I'm not sure, but I'm guessing it had to do with time and location, perhaps, relative to the stars. But how intriguing is this? And I think these are phoenixes. Wrong again. These are dragons. Boy, I hope none of the wealthy people out of Teton, wherever they live, find out about these things. They'll come over here and buy them away from the Chinese. The emperor made Matteo Ricci a very important collaborator because of his ability to correctly and accurately predict the eclipses. Zhang Heng was a prominent astronomer during the period 78 to 139 AD. These in turn were the great men of science, early science and astronomy in China. It was Jesuit priests that first came here and brought with them the astronomical technologies of the West, and presumably took back some of the concepts of the East. A picture of Isaac Newton, Galileo Galilei, Johannes Kepler, Nicholas Copernicus, whose bones I once stood very closely to in a church in Poland. They were ensconced in a column in that church. Ptolemy, Aristotle, William Herschel. This room is a tribute to all of the early scientists and contributors to astronomy in the world, Western and Eastern. How amazing such devices must have been in their time, since in my opinion, for someone to have the break down the technology, in other words, to reverse engineer this thing right now, would probably be in itself quite a challenge. I'm guessing that this is that map projection that allows you to show a sphere in a flat format, but this is probably one of the sky. In other words, the inside of the sphere as we see it from Earth. We take for granted the ease of knowing where stars are and finding them, etc., etc., and ignore these incredible precursors of that technology. Can you just imagine the knowledge implied by the devices here that I don't even know what they are? Like this one, which has a dial on it. And what's this thing up here, the two spheres, and this curious thing here? I feel like a caveman looking at an iPhone 4. This bowl, spherical half a bowl, has delineations inside of it. And so using this device in the center, it was capable of measuring the position of the sun and the full process of the solar eclipse. Wow. A huge globe, probably, of the constellations in the sky, all of which, plus much, much more, we carry in an iPod Touch or an iPhone on a simple app that costs less, I think, than $15, if that much. This is a steel yard clepsydra, and a clepsydra is apparently a water clock. Exactly how it works is interesting. So as water is siphoned from this large bucket into that hanging bucket, it affects the weight, of course, causing this arm to rise, and presumably somewhere in there time can be determined. And this is a water-powered Amarilla sphere in a tower. And we'll look at the innards here. That can't be part of it. That's just a thing, isn't it? Just a model of a tower? No. Maybe not. This is a simplified armilla made in 1439 and used for the same purposes as the Amarilla sphere. Simpler in structure and operation. Moved to the Purple Mountain Observatory in Nanjing in 1933. Notice it's sitting on a couple of turtles. Now we'll go upstairs to the top of the tower, where I think are reproductions of the original devices. Apparently the original devices were stolen by, they said, the Italians and the Germans. During the Boxer Rebellion, the French and the German troops stole these items, and it was not until 1902 that they were returned to China. According to one interpretive sign nearby, this is the largest observatory still in existence anywhere in the world. Largest ancient one. This item is an equatorial armilla in Spanish, made in 1673 for the purpose of determining true solar time, as well as the right ascension, difference, and declination of celestial bodies. And I presume from that knowledge you can then determine time. Beautiful looking, but relatively crude, you would actually think, for its size. Made in, it's called a sextant, made in 1673. The purpose of measuring the angular distance between any two stars less than 60 degrees apart. Of course, later, and maybe they even had them then, sailors would have a sextant. Also allowed for measurement of the angular diameters of the sun and the moon. I didn't know they had those things. Now what we'll look at is an azimuth theodolite made in 1715 for the purpose of determining azimuth and altitude of celestial bodies. Now consider, this is 300 some years ago. Well, a little less than 300 years ago, but not much. What will we see here in 300 years from now? Like many clocks in some railroad or bus stations or airlines, will we see commonplace, a series of clocks for various celestial bodies that we might choose to be going to? And the next one, an altazimuth, made in 1673, purpose of determining azimuth of celestial bodies. Let's go look up what azimuth means. But look at what effort went into creating this device. By comparison, imagine a spacecraft that most dominant features were huge characters that were embossed on or around it. This is an elliptic armilla, 1673, purpose of determining elliptic longitude difference and latitude of celestial bodies, as well as the 24 solar terms, whatever that means.